Hey, this is Mr. Easton, and today I'm going to be talking about partial products for multiplication. This will help you working with the first couple of pages of the work that I'm sending home during our 2 weeks off of school. This also leads us into doing the standard algorithm for multiplication, which I'm going to cover in my next video. So without further delay, let's get started. So we're looking at an equation right now, which is 32 times 6. Earlier in the year, we had built physical models with base 10 blocks. We'd put 3 10s going across the top up here with 2 more 1s, and we put 6 1s down the side. Now we're going to be going to more of a representational view, so instead of putting 3 10 sticks, we're going to just put a 30 covering this nice long line, and we're going to put a 2 covering these 2 dots. We're also not going to be using actual base 10 blocks inside the blanks. It's going to be more of a multiplication equation. So inside this inside this left-hand box, this box is a 30 across the top by 6 on the side box. So it's a 30 by 6 box, and we find the area of that box by doing 30 times 6. So inside the box here, we're going to write 30 times 6, and that equals, well, 3 times 6 is 18, so 30 times 6 is 180. In this right-hand box, right in here, it is 2 across the top and 6 on the side. Even though 6 is not labeled over here, we can see the 6 being here on the right, on the left, and so it still is the same length on the right as well. So inside that box, we're going to write a 2 times 6, and that equals 12. And so our answer to 32 times 6 comes from adding 180 plus 12. And while this strategy is not the most efficient, it is a great way to understand and see what is happening with multiplication. In the next slide, we're going to show an example of how this gets us closer to the algorithm without doing the picture, using partial products, and then we're going to move to the algorithm in the next video. So I'm going to move to the next slide. Now we're looking at 32 times 6, the exact same equation we had, but we're going to do it without a picture this time. And we're going to do this by writing down 2 equations that help solve this question. This question can really be broken up into 2 times 6 and this 3, but since it's in the tens place, it is a 30 times 6. And so over on the side here, I'm going to write down 2 times 6. Actually, I'm going to write down the 30 times 6 first. 30 times 6 and 2 times 6. And I'm going to solve both of those things. 30 times 6 again is 180. 2 times 6 is 12. These numbers should look familiar to you because they were in the model that we drew in the last screen. And we have 180 plus 12. You still add them up and you get 192. And so 32 times 6 is 192. This is less drawing, but still kind of getting at the same idea. We're going to look at one more example of what a model may look like, as well as what the partial products would look like without a model on the next screen. So in this model, I've went ahead and set up 245 times 4. As you can see going across the top, we have our 200, our 40, and our 5. And on the side, we have our 4, which needs to be labeled and then is not. Oops. So now we're going to go ahead and fill in some equations that can be used to represent the areas of the box. That first box is 200 times 4. And 2 times 4 is 8, so 200 times 4 is 800. In the next box, we have 40 times 4. 4 times 4 is 16, so it's 160. And then the last box, we have 5 times 4, which is 20, and then we add up 800 plus 160 plus 20. You get 980. So on the last screen, I'll show you the version of this that does not involve drawing a picture, just so you could use that in the future if you were wanting to. So we have our 245 times 4 here. So I'm going to write out the partial products here. 200 times 4 40 times 4, and 5 times 4. I'm getting those numbers because I'm looking at the value of this 2, which is 200. I'm looking at the value of the 4, which is 40. I'm looking at the value of the 5, which is 5. And I'm using this 4, my other factor, to multiply all 3 parts by. So I'm going to go ahead and solve 200 times 4, which is 800. We have 160 here. And we have 20 here. We add them up. We get 980. So using this should help you solve the first couple of pages of the classwork. We are going to learn the standard algorithm next, which is the most efficient way for a lot of questions to solve. Not all, but some, and that's the way that your parents also learned it in school, so a lot of you will probably enjoy that. Until then, this has been Mr. Eason with some online learning. Have a great day.